Hello, this is Tom Brinkotter, Product Manager for the Anritsu S412D LMR Master. This short video describes how to measure both talk-out and talk-in BER coverage on P25 systems. We will use example measurements made in downtown San Francisco in July 2009. First, I'd like to take a minute to review the product we used, which was the S412D. It's a small battery-powered multi-purpose instrument that is part of Anritsu's popular SiteMaster product line. Much like the other SiteMaster products, it can measure antenna SWR, distance to fault in cables, and show the spectrum of desired and interfering signals. The S412D has unique features to measure the new digital P25 two-way radio communication systems. It has a sensitive receiver for measuring P25 signals down to minus 110 and can see interfering signals to minus 135 dBm. It includes an internal GPS to tag measurements with time and location, and Anritsu provides free software to convert measurement files to Google Earth maps. And finally, the S412D, along with the entire SiteMaster family, is designed and manufactured and supported in Northern California. Our test scenario was to measure the talk-out and talk-in BER coverage from a repeater planned to be put on top of an 8-story building at the corner of Battery and Broadway in San Francisco. We used 1-watt handhelds at 145 megahertz for both the base and mobile locations. The base antenna was a vertical dipole, and we had duplicate S412Ds at both locations. We first predicted the coverage along our drive route using EDX Signal Pro software. The route, which was up Broadway, Columbus, Bay, Embarcadero, and back to Broadway, included a section of Bay Street which was shadowed by Telegraph Hill, which was visible in the photograph from the top of the building on Battery and Broadway. Looking at the coverage, the white area along Bay Street indicates the signal levels below minus 110 dBm. First, a decision was made to map using the standard 1011 Hz pattern. The S412D can measure P25 BER on a variety of signals, including live P25 voice traffic or control channel messages on a trunk system. We chose to use the TIA standard as our Kenwood TK5212 radios provided that test pattern. Only an LMR master in the vehicle would be needed if we were just doing talk out. But since we were doing both talk out and talk in, we had LMR masters in both locations. We did the measurements in 2 drives, one for talk out and one for talk in. Let's get going. So the talk out measurements, we set the repeater location. We hooked the two-way radio on the antenna at the repeater location and started transmitting the 1011 Hz pattern. In the vehicle, we put the GPS antenna on the S412D and, of course, the antenna for receiving the signal. We set the S412D to talk out coverage mode and the BER test pattern to 1011 Hz and set log data to on. Each second, the RSSI, or signal level, the BER, and the GPS location was logged onto a trace that's shown on the screen. Once a trace is complete, it's stored for later retrieval inside the S412D. Over 100 traces or 8 hours of measurements can be stored internally to the S412D. So these are the results. The upper right is one trace of 401 measurements. We used on the lower right master software tools to take that trace out and convert it to a file .kml format for Google Earth. The lower left is the Google Earth display showing colored push pins, green for good and red for bad, greater than 15% BER. To see the results of an individual measurement, you just click on one of the push pins, a balloon pops up showing both the power and the BER. The talk out measurements correlated very closely to the predicted coverage. So now we did another drive for talk in measurements. Here we transmit from the vehicle, and the S412D at the repeater location is connected to the antenna. Both of the S412Ds have to have their GPS receivers on and functioning to synchronize the resulting measurements. And to simplify management of the files, we hit escape on to eliminate any previous traces in the instruments. To further synchronize the sampling and measurements, we had operators at both locations press reset sweep and log data. This gets them synchronized to within 1 second. Although the S412D in the vehicle is only recording the location of the measurements, we did put an antenna on it so it saw a small portion of the P25 signal transmitted from the handheld. Without an antenna, the S412D in the vehicle would spend time searching for a P25 signal and not be synchronized with the other unit up at the repeater location. As a side note, up at the repeater location, we had a bandpass filter between the antenna and the unit to prevent overload from nearby FM and TV stations. Once the drive was complete, we took the traces from both instruments and brought them into the PC into Excel. We looked at the measurement columns and the GPS location columns and merged the files together to create one file with both the measurement and location. We then used master software tools to convert that file to .kml format, and that's shown on the lower left. In our talk-in measurement situation, the results were poorer than predicted and poorer than the talk-out measurements. And we believe this was due to a bus that was alongside the vehicle during the Columbus part of the route. This well illustrates the purpose of doing both talk-out and talk-in measurements. There's always a chance of an interferer or a local issue that causes them to differ. It would have been useful to go back to the location on Columbus where we saw the poor talk-in coverage and measure over time to see what was going on. We also, of course, had the spectrum analyzer and interference analyzer capability to hunt down any interference problems. So to summarize, both talk-out and talk-in BER coverage for P25 systems can easily be measured with the procedure outlined in this video. If you'd like more information on the S412D, go to our Anritsu site at us.anritsu.com or call 1-800-ANRITSU.